Okay, this is going to be the last video on our logarithm properties, and in this video we're just going to do some examples with algebraic expressions, and again this is going to kind of move us towards being able to solve equations with logarithms. So there's going to be two things we're going to do. We're going to expand logarithmic expressions, and then we're also going to condense logarithmic expressions. Now the expanding the goal is to have each logarithm having a single number or variable present. The variables should have exponents 1. Alright, so let's just look at an example here. We'll look at a couple maybe here. Let's just start with the natural log of 4x squared over the square root of y. Now before I do anything here, again, the first thing I always like to do when I see radicals and I'm working with logarithms is to convert to fractional exponents. So I'd have 4x squared over y to the 1/2 power. Okay, so now I'm going to go ahead and use my log properties. Now, you can sometimes, do these in one step, but I'm going to do it in two steps here. I'm going to do the quotient one here, and the quotient one would be that this is the natural log of 4x squared minus the natural log of y to the 1/2. Now, natural log of 4x squared, I still can't apply the power one there because I've still got two things going on here. Because remember, what's the goal? Each logarithm is to have a single number or variable present. Well, I don't have a single number or variable. I have a single number and a variable present there. So I'd want to split this apart and write this as natural log of 4 plus the natural log of x squared minus the natural log of y to the 1/2. Now the other goal is to have the exponents on all the variables to be 1, and we just use the power property for logarithms, and we rewrite this as natural log of 4 plus 2 natural log of x minus 1/2 natural log of y. And then we'd be done. We've expanded this logarithm out. Now, sometimes, and I'm okay if you do this, sometimes what we'll do is we'll just skip that first line and go from this expression here down to this one. And the way you can do this sometimes, I like to think of this if terms are in numerator and multiplied, we add. If terms are in denominator, we subtract. And to kind of illustrate this, let's look at another example of expanding these logarithms here. So let's do here the common log of 4x to the fourth over z cubed y to the fifth. Now, I don't have any radicals, so I don't have to change to fractional exponents, so I'll go ahead and just start writing them separate out. Now, if the terms are in the numerator, that means they're multiplied. If they're added, and if they're in the denominator, they're subtracted. So to expand this out, we'd actually get that this would be the log of 4, because the 4 is in the numerator, plus the log of x to the fourth, because x to the fourth is in the numerator, minus the log of z cubed, because I'm dividing by z cubed, and then it would still be minus the log of y to the fifth, because I'm also dividing by y to the fifth. And then to finish this off, of course, we use the power one, and this would be log of 4 plus 4 log of x minus 3 log of z minus the 5 log of y. All right. Now, condensing. Logarithmic expressions. We're literally just going to go in this process backwards. So what's going to happen is we're going to start with something like this here, and then we're just going to literally walk ourselves backwards in this process. So typically here, what you will do for condensing logarithmic expressions, we want a single logarithm with all the terms. Now, one of the things we typically are going to do here, typically you apply the power property first, then product and quotient. If I could spell quotient. Now, if you think about it, because we're condensing, we're essentially going backwards. That makes sense, because if we expanded, what was the first thing we did? We used the product and quotient properties, then we used the power one. So if we're trying to go backwards, essentially undoing what we were just doing, it would make sense that, well, first you would use your power, then the product and quotient one. So let's look at a couple examples of this. So let's look at 2 natural log of x plus 2 minus the natural log of x. So again, we're going to go exactly backwards on this, and so what would we do going exactly backwards? Well, this would first, we would apply this natural log, and it would be x plus 2. Now, careful, it's the entire thing, x plus 2, that's going to be squared. So we have natural log of the quantity x plus 2 squared minus the natural log of x. And then, because they're subtracting, this is going to be division. The other thing I like to think of it is if there's a positive in front of the logarithm, which there is here, we don't write the positive typically, it would go in the numerator. If it's a negative, it goes in the denominator. Now, I'll point out one mistake I see a lot of people making. The correct answer here would be then the natural log of x plus 2 quantity squared over x. So this is the correct answer right here. But the mistake I see a lot of people making, so this is a mistake, so don't do this, is I see them going from natural log of the quantity x plus 2 squared minus the natural log of x, and then writing this as the natural log of x plus 2 quantity squared divided by the natural log of x. And that's not correct at all. This is still two separate logarithms. This is not using the property correctly, so don't do that. All right, let's look at another example here. Let's look at 2 times the log of x plus 3 plus 1/3 the log of x minus 2 log of y. So we want to condense this into a single logarithm. Now, this one here, I purposely wrote this with square brackets because what that's indicating is that this 2 is multiplying everything. So before I can use my power thing, I really need to first distribute that 2. And of course, that's not too difficult. This would just be 2 log of x plus 3. Then 2 times 1/3, which of course be 2/3 log of x. And then minus 2 times 2 is 4 log of y. Then we go ahead and apply the power property again. So this would then be the log, and again being careful, this would be the log of quantity x plus 2 squared plus the log of x to the 2/3 power minus the log of y to the 4th. Now we can write this as a single logarithm. So this would be the log of, well, if it's positive or adding, it goes in the numerator. So I'd have x plus 2 quantity squared times x to the 2/3 power. And then subtraction goes in the denominator over y to the 4th. Now we have one more step we really should do here. Because I've got a fractional exponent, let's convert that back to the radical form. So this would be log of x plus 2 quantity squared, and then this would be the cube root of x squared divided by y to the 4th. And sometimes when we have things like that, I like to write a multiplication sign down or just put another set of parentheses just to make sure we're clear that that 3 is associated with the root, so it's the cube root. Okay? So this marks the end of our videos on logarithmic properties. The next set of videos is going to talk about solving exponential and logarithmic equations. Now we'll have a couple videos talking about that.